Hi guys, let's start a new chapter which is called circles. So before we start new concept that we learned this year, let's quickly revise what we already know. So a circle is the shape that you see here. It has a center. This is a semicircle which is half a circle. OA and OB are equal. In fact, any other point which is on the circumference is equidistant from the center, and this is known as radius. And the line which passes through the center and touches the circumference at 2 points is known as the diameter. Exterior point, any point which is outside the circle. So D and E are in this example exterior point. Interior point, any point which is inside the circle. In this case, I and J are interior points. Concentric circles are circles with the same center. In this case, these are different concentric circles. Equal circles are circles which have the same radius. They can also be called congruent circles, which means same shape and same size, in this case same radius. Circumscribed circles are circles which pass through the vertex, or rather all the vertices of a polygon. This is a circumscribed circle for a triangle. This is for a square. Inscribed circle is a circle which touches all the sides of a polygon. In this case, this is a circle inscribed in a triangle. I repeat, it should touch all sides only once. This is not an inscribed circle because this is touching sides more than once. Arc, major and minor. Arc is basically part of a circumference. The smaller is known as minor. The major one, or which is the bigger one, is known as the major arc. Let's look at some other things, which is segment. Segment is a part of a circle which is bounded by a chord and an arc. So chord and minor arc gives a minor segment. Chord and major arc gives a major segment. Next, sector. Sector is area bound by the arc and the center of the circle. So area bound by the arc and the center. Obviously, the smaller part, which is the smaller minor arc, the area is minor sector. Major arc, the area is major sector. Next one. These are two theorems that we've done in class 9, and we'd use them extensively in class 9. One, line drawn from the center of a circle to bisect a chord makes an angle of 90 degrees with the chord. So what this means is, if AP is equal to BP, let's call this point P. If AP is equal to BP, then what we have is OP is perpendicular to AB. So if AP and BP are equal, then OP is perpendicular to AB. And the converse of this would be, what is given is that OP is perpendicular to AB. So any line which is drawn from the center of a circle to a chord which is perpendicular to it basically bisects the chord, which means AP would be equal to BP. We used these two properties extensively last year. Let's look at the next theorem that we've done last year, which is if two chords are equal, then they are equally far from the center, which means equal chords are equidistant from the center, which means what is given is, if AB is equal to CD, then distance of AB from the center, which is O, would be a perpendicular from the center to the chord. In this case, OM would be equal to ON. And the converse of this would be, if two chords are equidistant from the center, then they are equal, which means if OM is equal to ON, and then AB is equal to CD. Good. Let's look at the next one. So this is a new one which we are doing this year, which is angle subtended by an arc at the center is double that which it subtends any other point of the circumference. So what it's saying is, the arc AB subtends an angle of AOB at the center, and arc AB subtends an angle of ACB at any other point on the circumference. So what we need to prove is angle AOB is 2 times angle ACB. Now this proof is in your syllabus, so you would need to know this. So let me just join AO and let it extend up to another point D here. So that's something that we'll write. Join, not AO, OC, and extend it to D. So let's say we've extended it here. Let's see how does it help us? Now in triangle OAC, we get two triangles. I'm talking about OAC. OA and OC are equal because they are the radii of the same circle. So radii of same circle, which means triangle OAC is isosceles since two sides are equal. What this means is that the base angles are equal. So angle OAC is equal to angle OCA. Let this be equal to x. So this is x. This is also equal to x. Next one, let's look at the exterior angle AOD, which is I'm talking about this angle here. Now this angle is equal to the sum of opposite to interior angle, which means x plus x, which is 2x. A reason would be exterior angle of a triangle is equal to sum of opposite to interior angles. Right? Now let's try and do the same thing for the other triangle OBC. In this case, in triangle OBC, next one that I get is OB is equal to OC, which is radii, and then we will have triangle OBC is isosceles. What this means is angle OBC, no, not this way, angle OBC would be equal to angle OCB. Let this be equal to y. So this angle is equal to y. This angle is also equal to y. Again, we look at the exterior angle. So exterior angle BOD would be equal to y plus y, which is 2y. Same reason. So this is 2y and we got this as 2x. So angle AOB is equal to 2x plus 2y, which is 2 times x plus y. And we have angle ACB is equal to x plus y. So from 10 and 11, what we get is angle AOB is 2 times angle ACB. So angle at the center is 2 times the angle at any other point on the circumference. This is for an arc. We will use this property extensively in this chapter. Good. Let's look at the next one. The next one says angle in the same segment of the circle are equal. Now, the proof for this is not required in our syllabus, but let's see what it means. So I have looking at the segment or the arc here. In this case, I'm looking at the arc. Well, obviously, if I make the chord, this is the segment. So angle in the same segment are equal, or made by the same chord or made by the same arc are equal. In this case, the angle that it makes is ACB, and this also makes an angle ADB. So angle in the same segment are equal, which means angle ACB would be equal to angle ADB. The proof is not in our syllabus. So again, a property that we'll use extensively, angles in the same segment are equal. Angles in same segment are equal. So we have done two till now. One, which is this, angle in same segment are equal, and the second one, angle at center is equal to 2 times angle at circumference. Good. Let's look at the next one. It says angle in semicircle is a right angle. So in this case, what we need to prove, so AB is basically the diameter, O is the center of the circle. I need to prove that angle ACB is 90 degree. So let's see how we can prove it. We already know that the arc AB, if I look at this arc AB, this subtends an angle ACB at some part of the circumference. So arc AB subtends angle ACB at circumference, and it also subtends angle AOB at center. Yes, it subtends ACB at circumference, it subtends AOB at center. We already know angle AOB is equal to 2 times angle ACB. We've already done this. since angle at center is equal to 2 times angle at circumference. Now in your exam you will not write it the way I am writing it here, you will write the full sentence, but since we will be solving a lot of questions, to save time I am writing it in this form. We already know angle AOB is equal to 180 degree. Reason, this is a straight line. So angle in a straight line is 180 degree, which means what I get is 180 degree is equal to 2 times angle ACB, which means angle ACB is equal to 90 degree. That's what we have to prove. Done. So by now we've done 3 things. 1, angle in semicircle is equal to 90 degree. Next, angle in same segment are equal. And the third, angle at center is equal to 2 times angle at circumference. So 3 new properties that we've done now. Good. Let's look at the next one. The next one is about a cyclic quadrilateral. Now what does a cyclic quadrilateral mean? Cyclic quadrilateral means a quadrilateral whose all 4 sides or all 4 vertices touch a circle. So in this case A, B, C, D, all 4 vertices touch the circumference of a circle. That's why this is a cyclic quadrilateral. Now property 1 of cyclic quadrilateral is that the opposite angles are supplementary, which means angle D here and angle B here, if I add them, they will be equal to 180 degree. Similarly, DAB plus DCB will be equal to 180 degree. The proof of this is in your syllabus. So let's just look at this proof. So what we already know is angle A. So let's look at this arc AC. So AC subtends an angle of AOC at the center and ADC at the circumference. So angle AOC would be equal to 2 times angle ADC. This is the reason angle at center is equal to 2 times angle at circumference. Correct? So this is something that we already know. Next we know is angle ABC, which is this angle, which is the angle which is at center. So in this case we are looking at the major arc here. So the major arc is making the angle ABC and it is making the angle reflex angle AOC. So let's just write it for reflex angle then. Reflex angle AOC is equal to 2 times angle ABC. Same reason. We know that the total angle around O is 360 degree, which means let's add 1 plus 2. So if I add 1 plus 2, what I get is angle AOC plus reflex angle AOC is equal to 2 times angle ADC plus 2 times angle ABC. Reflex angle plus this angle is 360 degree upon 2 would be equal to angle ADC plus angle ABC, which means this is equal to 180 degree. Done. Similarly, if I take this 2 angles, then I will be able to prove that angle A here and angle C here are supplementary. So quick revision of the 4 things that we've done till now. Angle at center is equal to 2 times angle at circumference. Number 2, angle in same segment are equal. Number 3, angle in semicircle is equal to 90 degree. Number 4, opposite angle in a cyclic quadrilateral are supplementary, meaning they add up to 180. So 4 things. Let's look at the next one. This is the last property that we do, and after that we can solve some questions. So this property says exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Proof for this is not required. In any case, even if this is required, it's very simple. So what we have is angle BAD, which is this angle, is equal to the exterior angle. This is only for a cyclic quadrilateral, which means all vertices should touch the circumference of this circle. So this is basically it. In case you want to still understand it, let's say this is x. How much would this angle be? Yes, this would be 180 minus x. The reason being that these two are supplementary. So x plus 180 minus x would give us 180, which means these two are supplementary. Next, this angle here and this angle here are also supplementary. Why? Because this is a linear pair. So this angle is x. So that's what they wanted us to prove. This angle and this angle are equal. So let's just quickly write the 5 things that we've done. Angle at center is equal to 2 times angle at circumference. Number 2, angle in same segment are equal. Number 3, angle in semicircle is equal to 90 degree. Number 4, opposite angles in cyclic quadrilateral are supplementary. And number 5, exterior angle of cyclic quadrilateral is equal to opposite interior angle. 5 new properties that we've done. Let's solve one question before I finish this video. So let's look at this question number 1. It says in this triangle, angle OAB is equal to, and angle OCB are 30 degree and 40 degree. So this is 30 degree and this is 40 degree. We need to find angle AOC. So unless mentioned, angle AOC is always a normal angle, not the reflex angle here. So any suggestions? Right? So let's look at this. Let angle ABC is equal to x degree. So if this is x degree, how much would AOC be? It will be 2x, which means therefore angle AOC is equal to 2x. Reason, angle at center is equal to 2 times angle at circumference. I repeat, you will not be writing this in your exam because you will not get marks. ICSE board doesn't allow the use of such short forms. Next, so if this is 2x, how much is this angle? The reflex angle. Yes, it will be 360 minus 2x because angle around a point is 360 degree. So reflex angle AOC is equal to 360 degree minus 2x, which means this is 360 degree minus 2x. So now let's look at the quadrilateral. In quadrilateral AOCB, I have 30 degree plus x plus 40 degree plus 360 degree minus 2x. The sum of 4 angles is equal to 360 degree in a quadrilateral. 360 and 360 gets cancelled. So this is 70 minus, not 2x, minus x plus x minus 2x is equal to 0, which means x is equal to 70 degree. They want us to find AOC, which means angle AOC is equal to 2x is equal to 140 degree. Done. That finishes this video for me. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.